Hello, my name is Dobromir Filip and I am a PhD candidate at the University of Calgary in Alberta, Canada. Today I am going to speak about our recently published article in gastrointestinal endoscopy. The clinical utilization of capsule endoscopy is currently limited to small lumen organs, although there is a significant recent interest in extending this technology to colonic application. However, in wider lumen organs, such as the colon, these capsules stumble and may potentially miss important lesions, resulting in incomplete imaging of the organ. In addition, this technology images mucosa in collapsed state only and may miss lesions located within collapsed segments of colonic epithelium. The bulk of evidence evaluating colon capsule endoscopy in colorectal cancer screening setting has demonstrated that it is inferior to screening colonoscopy. Previously, we had an abstract in DDW demonstrating feasibility and a vast improvement of capsule-based imaging in the canine colon with an innovative imaging method of gastrointestinal tract using self-stabilizing capsule endoscope. The self-stabilizing capsule endoscope design consists of an inner capsule endoscope that has an expandable component attached to its trailing end. The whole device is enclosed in a colon targeting shell. Here we can see animation that shows the planned application of the device. The self-stabilizing capsule endoscope is orally administered and traverses the alimentary canal by peristalsis. Upon arrival at the colon, the outer shell dissolves, activating the inner capsule endoscope and the self-stabilizing component, which expands and forms a hydrodynamically stabilized structure. The whole implant traverses the colon with the imaging unit being significantly stabilized. Our goal in this study was to quantitatively compare the detection rate of surgically implanted intraluminal suture marker lesions for unmodified Myrochem capsule endoscope, custom modified self-stabilized version of the same device, and standard colonoscopy as a positive control in an acute canine model. This study was performed on 4 female mongrel dogs that underwent laparotomy. Following this procedure, we have passed intraluminally silk sutures to create suture marker lesions in the colon. Here we can see an example of implanted intraluminal suture lesion. 5 to 8 such lesions were randomly simulated per animal at different locations in the most distal portion of the cecum, the proximal colon, and the mid-colon, and verified intraluminally using endoscopic visualization. The capsule catheter deployment system was used to position either the unmodified capsule endoscope or the self-stabilizing capsule endoscope into the colon beyond the most proximal suture marker lesion. The animal was then given a bolus intravenous dose of neostigmine to induce strong propulsive colonic peristalsis and propel the capsule through the colon. Upon verification of the neostigmine clearance from the blood circulation of the animal, another capsule, alternative to the previous one, was administered in a similar manner. Each animal received unmodified and stabilized capsule endoscope in random order. Screening colonoscopy was performed by an experienced gastroenterologist after the capsule endoscopies and upon the clearance of neostigmine. Suture marker insertion and capsule placement was not performed by the gastroenterologist to maintain blinding. Here we can see fully expanded self-stabilized capsule endoscope. Here we can see a side-by-side comparison between the conventional capsule endoscope on the left and the self-stabilizing version of the same device on the right. It is important to note that both videos are running at the same speed. The conventional capsule endoscope tumbles significantly, which results in incomplete imaging. On the other hand, the self-stabilized capsule completely eliminates tumbling, reduces its transit velocity, and self-centralizes itself during peristaltic waves. The table shown summarizes the results of our study. The overall detection rate of suture markers was highest with colonoscopy at 100%, followed by self-stabilizing capsule endoscopy at 86% and conventional capsule endoscopy at 31%. A post-hoc comparisons using Dunnett's test indicated that the mean rates for the detection rate using colonoscopy and self-stabilizing capsule endoscopy were significantly higher than these of the conventional capsule endoscopy. In two tests, we had a poor bowel preparation. However, interestingly, the self-stabilizing capsule endoscope performed well, reaching detection rate in the range of 80%. In case of a good bowel preparation, self-stabilizing capsule endoscope achieved 100% detection rate, while the conventional capsule endoscope only achieved a 12.5% detection rate. It is important to note that in this reported design, the emphasis was placed on demonstrating the stabilization feature, and in our testing, we assumed that the outer casing had reached the targeted organ. Thus, we used a plain gelatin-based cover for the capsule. The results from this preliminary study show that self-stabilizing capsule endoscopy has significantly improved detection yield over capsule endoscopy, with detection rates approaching conventional colonoscopy even during rapidly propulsive colonic peristalsis. At no time in this study did the self-stabilizing capsule tumble within the colon. This method appears to distend the wall of the colon due to the stabilizer over and above fluid effluent alone. Self-stabilizing capsule endoscopy is the first screening modality that can deliver this very important feature in non-invasive colorectal cancer screening. Although the reported results are very encouraging, further tests are needed to investigate the performance of the self-stabilizing capsule endoscopy in humans, particularly with respect to timed launching in the cecum, premature expansion or obstruction in the small intestine, detection of natural colonic polyps, and the ability of the device to pass through sharp colonic flexures while imaging them systematically. With respect to safety, theoretical consideration of obstruction and perforation do not appear likely from our mathematical modeling and the limited experimental data of 8 acute canine animals. However, given the theoretical potential of self-stabilizing capsule endoscope to become impacted or obstructed in the gastrointestinal tract, a remotely controlled separation capability between the stabilizing and the imaging portions has been integrated in the prototype design. Preliminary laboratory testing provided encouraging results without adding any significant space requirements. In summary, the proposed self-stabilizing capsule endoscopy delivered highly significant improvement in suture marker lesion detection when compared to conventional capsule endoscopy. The self-stabilizing component could be added to capsule for colorectal cancer screening applications, which may improve the diagnostic yield of capsule endoscopy in large lumen organs. Large-scale human trials are necessary to determine the efficacy of the proposed device in clinical practice and its performance characteristics compared to colonoscopy. Thank you very much.